Okay, we have to factor 6x squared plus x minus 12. And the complication with this is that there is more than one way to break apart 6x squared and multiple ways to break apart the 12, the factor of the constant term. And so, to avoid trial and error that could go on indefinitely, we want to come up with some other kind of method. And so the title, I don't know, of this method will be factoring with the aid of a factor square. It's a 2 by 2 kind of an array. And so that's what we're going to use, where we make a box, and in the box we have it broken into 4 pieces, four separate boxes. And we start the process by multiplying 6 times the negative 12, the a, the coefficient on x squared, times the c, the constant term. The goal in mind behind this method is to make the factoring simpler, to make it just as simple as factoring something that has as its leading term just an x squared. And so in order to do that, though, we need to do a couple things first. And so we start off by multiplying the a times the c. So we multiply 6 times the negative 12. And what we get from that, what we get from that is a negative 72. Okay, great. Now, inside the squares, what we put are the leading term, the 6x squared, and the constant term, the negative 12. But we have to put them in not just any square. We have to put them in the top left corner for 6x squared and the bottom right corner for the constant term, negative 12. And then what we need to find for these, in order to figure out what to put in these other 2 squares, by us doing this multiplication of the a and the c, it's our job now to find 2 numbers, m and n, that multiply to negative 72, and when we add them together, we get a positive 1. Okay, it's this here that kind of makes it just like factoring in a quadratic that has x squared as the leading term. So 2 numbers that multiply to give you 72, essentially that are 1 apart, or negative 72, essentially that are 1 apart from each other. We'll say one of them is the negative 9, and the other one is a positive 8. I'm sorry, that's totally wrong. Positive 8 and a negative 9 in order to end up with a positive 1. Great. What do we do with these? We fill in the other squares, not just with these numbers though, with these numbers as coefficient on x. So it doesn't matter what you put where. And so I'm going to put the 9x here and the negative 8x here. Okay, great. Just a couple steps away from being done. We have to factor out the greatest common factor from each row and each column. And so here's the first row. The greatest common factor amongst the terms that are in this row is as far as the coefficient is concerned, it's a 3, and they both have an x on them. So we factor that out. On the second row, the greatest common factor that the terms have in terms of the coefficient, actually it would only be the coefficient, it is a negative 4. If both of the terms are negative, then take it out as a negative. We could take a positive 4 out, but if they're both negative, we'll take it out as a negative. when one is positive and one is negative, we'll take it out as a positive. That's what we get when we come to the first column. What these have in common, coefficient-wise, is a 2, and they both have an x. And then with the second column, what these have in common is a 3. We'll take it out as a positive 3. Okay? And so, believe it or not, we are actually done. How does 6x squared plus x minus 12 factor? What we have factored out become the parts in the binomials that multiply to give you the original. We have 3x minus 4 and 2x plus 3. And if you want to double check it, it's 6x squared multiplying the first together, multiplying the outer together, we get 9x. That's where that comes from. Multiplying the inner together, we get negative 8x. And then multiplying the last together, we get our negative 12. The middle terms combining to give you the positive x. Okay, so it's factor square method. Start by multiplying the coefficient on x squared and the constant term together, and then it breaks down to be two numbers that multiply to give you that number and add to give you the coefficient on the x term. Break apart your squares to be the leading term goes in the upper left corner, the constant term goes in the lower right corner, and then what goes in the other boxes would be the result of figuring out the two numbers that multiply to give you that product and that add together to give you the coefficient on x. But when you put those in, don't just put them in as numbers, you put them in as x's, and then you factor out each column and each row. It takes away the guesswork of trying all the different combinations, and which could take up much time. Okay.